Kia ora koutou katoa nau mai, here mai ki tēnei hui iparangi. Good evening, everyone, and welcome to our webinar on understanding and preparing for catastrophic electricity loss. I'm Pia. Myself and Sam will be your facilitators for this evening's discussion. We are Islands for the Future of Humanity, an organization that emerged following the 2023 Aotearoa NZ Catastrophe Resilience Project, which examined New Zealand's vulnerability and resilience in the face of a potential Northern Hemisphere nuclear war. We are a nonpartisan think tank dedicated to helping island nations build resilience against global catastrophes through evidence-based research and engagement. While we're starting here in Aotearoa, our work aims to benefit island nations worldwide. Tonight's session will explore one of the most critical yet understudied risks facing modern society, the potential for catastrophic electrical system failure. As we've seen from recent events like the 2024 blackouts, in Cuba, modern dependence on electricity creates profound vulnerabilities. We'll examine potential causes from solar storms to electromagnetic pulse events and discuss strategies for building resilience. We are fortunate to have an outstanding panel of experts joining us today. David Korowicz, who is a physicist and human systems ecologist, has worked for over 15 years on global systemic risk and societal preparedness. This has included analysis of systemic vulnerability, destabilization and collapse dynamics, and the scope and limitations of preparedness. In various roles, he has consulted at high level with government, military, and institutional partners, as well as with civil society. Currently, he's working as an independent consultant and involved in a number of systemic risk-related networks, including the Accelerator for Systemic Risk Assessment. Associate Professor Caroline Orchiston is a social scientist who specializes in collaborative disaster risk reduction to support emergency management and community resilience to disruptive events. She was the science lead for the award-winning AF8, the Alpine Fault Magnitude 8 program from 2016 to 2023. David Keat is a retired oil industry engineer and senior executive. His career included 19 years in Northland at the Marsden Point oil refinery, and ultimately as refining manager. He also spent 15 years in senior executive roles in very large oil and gas companies in the Middle East and Southeast Asia. David has hands-on familiarity with operating large, complex infrastructure under all conditions, including power outages. His experience also includes designing and managing very large projects and dealing with the associated technical, strategic, and corporate challenges. Florian Ulrich Jehn, who we're not seeing yet, but we might later, but he is here on audio so far, does research in food security, climate, and civilizational resilience, and also leads the data science work at the Alliance to Feed the Earth in Disasters, exploring solutions to prevent global famine from catastrophic events. He also regularly writes the newsletter Existential Crunch, where he summarizes research around societal collapse. And Dr. Matt Boyd, an independent global catastrophic risk researcher, owner of Adapt Research, and our executive director of Islands for the Future of Humanity. Matt recently presented findings of the NZ-CAT project at the 2024 Cambridge Conference on Catastrophic Risk. We'll begin with a 10-minute presentation from Matt to frame our discussion, and we encourage all the audience to please use the chat to engage with each other, and also the Q&A function to submit questions for our panel. And without further ado, I'll hand over to Matt to get us started.
Wonderful, thank you, Pia. Just let me bring up my presentation. Which you should see now. So, right, I will speak for about 10 minutes to set the scene for our exciting panel discussion on catastrophic electricity failure. So, first of all, just oops, the slide doesn't want to change. Don't know what's going on there. There we go. So just a bit of background about islands and our previous work. Basically, if we look back to 2023, our NZ-CAT project found that New Zealand might resist some of the effects of nuclear war and nuclear winter due to isolation and a moderate climate. And furthermore, island geography almost certainly led to less deaths in the COVID-19 pandemic. And some of our previous research has also found that there was less impact on islands from past volcanic winters. However, on the other hand, New Zealand is highly vulnerable to shocks that threaten the supply of goods and services, especially liquid fuels, and including catastrophic electricity loss. So resilience is needed, and there are strong reasons to over-engineer resilience in islands. It is not just to protect the domestic populations, but for example, New Zealand can feed 8 times its number through food exports if it remains functioning. New Zealand is also often cited as a potential refuge for humanity, a place where societal complexity might persist through a truly global catastrophe. And so our organisation, Islands for the Future of Humanity, provides analysis and options that could help sustain islands through the worst of times. But what is catastrophic electricity loss? Well, I recently interviewed Dr. Simon Bluin of the Alliance to Feed the Earth in Disasters and lead author of a study modelling US food supply after a catastrophic electricity failure. And he explained to me that catastrophic electricity loss can basically be conceived of the loss of electrical supply to 5% or more of the world's population for a period of more than a month. Now, this is unprecedented, but a possible scenario. And you can watch my in-depth interview with Simon at islandfutures.earth or on YouTube at Island Futures. But basically, what we see is that this kind of scenario would result in national or even global impact rather than regional, potentially with no external aid coming, with a long period of impact such that slow processes can break down, like agricultural production, for example, with ongoing domino-like degradation of systems, and even cessation of the inputs for provision of mass relief, like supply of food or water. These are low probability, but extremely high impact scenarios, which are potentially unmanageable without investment and planning beforehand. And several classes of threats could lead to this sort of scenario, including physical damage to systems, cyber attacks for system controls, supply disruption to critical components required for maintenance and repair. Even loss of skilled operators over time could lead to inability to sustain systems. But we'd like to focus on 2 particularly dire threats, those of electromagnetic pulse from high altitude nuclear weapon detonation or severe solar storms. And it is worth noting these last 2 specifically, as they seem to have the potential for the greatest worst case impact. And the risk may be increasing due to, for example, the 2025 solar activity maximum and the deteriorating geopolitical situation, with UK PM Keir Starmer warning just yesterday of a, quote, new era of insecurity as he increased UK defence spending. And so the impact of a solar storm could cause widespread problems with electricity supply. And acknowledging this potential, New Zealand's National Emergency Management Agency has published a space weather response plan, which specifically states that critical infrastructure may be disrupted for long periods. And we must say that NEMA's plan is a great start, and it has been exercised in August 2024 and will be again in April 2025. And these exercises have led to iterative refinements. NEMA has also just released its Catastrophic Event Handbook, which is a hazard agnostic manual that includes a focus on things like mass relief of food and water, logistics, lifeline utilities, and problems with them like electricity. However, this Catastrophic Event Handbook assumes things like international aid will eventually arrive, that there is a functioning port and a functioning airport, and these may not be the case and actually need to be ensured ahead of time. Neither of these plans extends beyond sort of a short-term recovery phase, by design. And also by design, these plans do not detail what might be done ahead of time to optimize infrastructure and resources so that impacts can be prevented or mitigated. The response aspects of these plans assume present resources rather than proposing what investments might help reduce these risks. And our organization is particularly interested in these upstream solutions, thereby ensuring well-placed islands are able to ride out global catastrophes. But perhaps the most worrying threat to the electricity supply is the electromagnetic pulse from high altitude detonation of nuclear weapons. This is because there could be instantaneous continent-spanning impacts. And it would not take many detonations to disable a large portion of global electricity supply, while at the same time being harmless to humans. And Stephen Starr doesn't sugarcoat this in his detailed blog description of an EMP attack on the US, where he says society may suddenly stop working. And even from New Zealand's point of view, a detonation over the east coast cities in Australia aimed at disabling US military communications could impact New Zealand. So there are several reports out there relevant to catastrophic electricity failure, and I just want to point to two of them. One is a report by the German Office for Technology Assessment from 2010 that determined that after just a few days, critical infrastructure and services would collapse despite emergency measures, leading to a national crisis. And we get more of a flavor of this when we look at Simon Bluen's et al.'s 2024 modeling study, where they showed that a nationwide disruption of US electricity supply, either due to a cyber attack or a nuclear EMP, could threaten famine through effects on food supply chain, even in a highly productive country like the US. And the graph shows an optimistic green line and a pessimistic gray line scenario for return of electricity supply on the top, and on the bottom, it shows potential for food consumption to drop by over 50% for many weeks in the pessimistic scenario. And quantification like this is important to get an idea of the scale and potential resource needs. We put some of these problems and questions and scenarios to NEMA and asked them some somewhat probing questions, and in part they referred us to the New Zealand Lifelines Council National Vulnerability Assessment, which illustrates the interdependencies among critical utilities. And one example shows that electricity supply is dependent heavily on telecommunications for things like grid coordination, but telecommunications are heavily dependent on electricity. And so it may be hard to find a pathway to restoring function, leaving the electricity out for a long time. And then there's essential functions that are not included yet in these kinds of analyses, such as off-road machinery on farms or data centers or things like this. And complementary to this kind of analysis is local research. For example, the research by Alana Ware et al., who have studied interdependent infrastructure systems in Taranaki and found that seemingly redundant infrastructure networks may actually be highly susceptible to disruption when considering realistic hazard scenarios. So there is scope for ongoing redesign. And New Zealand's vulnerability includes isolation and maintenance issues, but also food distribution, water systems, transaction systems and payments, health services, and communication and coordination, all of which are dependent on electricity. And vulnerability assessments to date generally do not contemplate long-term or global disruption across months or even years, or New Zealand's connectivity with the world through digital and trade connections. And these assessments have focused largely on the robustness of present infrastructure rather than what doesn't exist yet but could or should. And things like payment systems have been left for future iterations of these vulnerability assessments. And we don't often get quantification of the severity of impacts. And there's a frequent focus on things like hospitals as exemplars of the most critical services, which underscore the large focus on disruptions of hours or days, whereas at different timescales, other systems may be more important, like agricultural machinery, milking sheds, or the unloading and loading of ships. And so in our recent blog, we posed a range of basic questions. But importantly, we asked, what consequences are expected from these sorts of scenarios, and how could investments ahead of time prevent or mitigate these? What resources or capital stocks would help in response and recovery? So just finally, to reiterate, catastrophic electricity loss is a common consequence of many large-scale hazards. It could occur in the absence of other infrastructure damage, and the risk may be increasing. Investment is warranted because although these are low probability events, there is a huge annualized expected harm. And our own research has found that a majority of New Zealanders support specific plans and even a commission or agency to prepare for catastrophe. And a UK study has found that a significant majority of people favour spending significant resources on these sorts of issues. So the public understands the efficiency resilience trade-off. 2025 is no longer business as usual. We need agreed solutions now, especially for remote islands. So that's all from me by way of contextualization and introduction. And I'll throw it back over to you, Pia, to get us started with a fascinating panel discussion. On mute, I think, Pia.
We'll just dive into some questions for the panelists, and I encourage our panelists to feel free to talk about what you think is most important for our audience to understand about these issues. I appreciate we have an abundance of Davids today, so I'll try to mention David Korowicz or Dave Keat, and beginning with Dave Korowicz. David, you've worked on large-scale risk assessment through organizations like the Geneva Global Initiative and the Accelerator for Systemic Risk Assessment. Can you briefly explain the role of these organizations and share how they've shaped your approach to systemic risks like catastrophic electricity loss?
Also on mute.
Thank you very much, Pia. Well, the Geneva Global Initiative is now over, but it was an effort in about 8 years ago to engage with governments on the need to prepare for increasing systemic disruption, including the possibility of catastrophic and irreversible systemic failure. And it was on one side about how do we engage with governments, etc. And the other was, well, what would you say to a government or to society to do? How do you respond rather than saying, well, here's a problem? So that involved really engaging with people and organizations who are doing good things in the world to see how we could learn. So that would have been the Nordic countries in terms of civil preparedness, and some military organizations to see, well, what would you do in such a catastrophe? So that was its role. It was a small organization, and it is now defunct. But it was very interesting in terms of it was set up by myself amongst a group of others to really address, I think, those sort of critical issues. The Accelerator for Systemic Risk Assessment, I'm just part of the network, so I'm not part of setting up or organizing it, but its focus is on bringing together researchers, other practitioners to do with risk from around the world and say, how do we understand our evolving risk environment? Because we've obviously lots of drivers of risk, from climate change to whatever Trump is doing to straining financial system. To how do we respond? So how do we find ways of looking at an integrated view of risk? How do we respond? And how do we catalyze a response? So that would be in the broad, those two organizations.
Great. You've also run community-based exercises in Ireland using an electricity grid simulator. What did you learn from those experiences, and what practical lessons can we apply to preparedness and response?
Well, there were a number of reasons for wanting to do it with the public, literally trying to get people together in communities and say, do you want to play a game for an afternoon? And it goes through the whole process of things going wrong, things looking scary, and it's this feedback process with the group where they ask themselves questions. How do you make sense of what's happening at this point? How do you respond? Now, the reasons for it, one was I experienced a lot that when talking to people with civil services or governments, they were pretty terrified often of saying, well, how do we talk to the public about this? Because it's not optimistic, it's kind of scary. And what I wanted to show was, well, when people are given the opportunity, it can be engaging, and increasingly in our increasingly unstable world, it can be a way of giving people, creating agency for people so people can get control and responsibility and understanding. And one part of that understanding is complex interdependent systems that people aren't going to read journal papers on this, but that practicality of it is very useful. The second is in terms of saying, well, what do societies do? How do they prepare? It's a way of pointing, here's a way to begin, get people engaged. And in a time when we're likely to see a lot more socioeconomic stress, it's a way to get people maybe off the less off more off social media and more onto saying, how do we come together? How do we deal with these problems? And then for government, for the whole of society, it's actually just practical preparedness. It contributes to that. So there's a lot of reasons. And what I found was that firstly, people do really find it engaging. They find, and we're doing something important. This is really important. We have agency, we meet our neighbours and we work out together how we can build resilience or build capacities into our communities.
Yeah, fantastic.
Yeah, but can I just jump in on that? I'm a big fan of wider engagement and these sorts of exercise, well, both exercises in general and engagement in general. And I mentioned how NEMA has exercised their plan and so forth. I would love to know if the findings from those exercises not only feed into redesigning the plan, improving the response plan, but also perhaps come up with lists of upstream infrastructure investments and so forth that government could invest in. And I know there's processes in New Zealand like the Infrastructure Commission's Infrastructure Priorities Program, and I would love to see community exercises that come out with a list of, well, maybe these are the infrastructures we need, and that kind of automatically feeds into those priorities programs without people having to make submissions themselves, as individuals from the community. So yeah, I don't want to talk too much about that, but structures like this I think could be really useful. I'm sure Caroline's got a lot more to say about that sort of thing.
Super. Well, further in that vein, David Korowicz, both you and Matt participated in a role-play simulation at the Cambridge Conference on Catastrophic Risk. How valuable are these exercises and who should be running them?
Well, it was a pretty short one, and it was more fun, I think, than we're going to solve the problem. And it was a big catastrophe; everything was going down. But look, I think they're very like exercises in the broad, be it the big complex ones that governments would run to the communities ones, are all particularly useful because they force people to think through problems, and a well-designed exercise will have, surprises thrown in that keep people sensitive to how you consider the complexities of risk. And it's also how you learn about response. So I think they're very useful. Who should be running them? Well, I think those whose responsibility it is at government level. So they could be national contingency agencies if there are those sort of things. I really think that communities, if it's a well-designed system, can, and when I say communities, it would be not just the people in the community, it would be the local government, it would be the emergency services, it would be tied into the exercise. That ideally they could be run by people themselves, that are with minimum input from external people if they're well designed, because you really want to get them out. You want to get people as quickly engaging with these sort of processes, exercises, simulations as possible.
Lastly for now, David, what do you think are the limits to preparedness for such a catastrophe? How do we accept risks that we can't fully mitigate?
I think that's just, this is what we have to deal with. You go through, my feeling is that after any major catastrophe, it will be irrecoverable because you won't recover the financial system. And I don't mean just the financial infrastructure. I mean the the role of money, finance, credit, as a space-time organizer for system integration globally. So every transaction has a money, every piece of trade has money or credit. And if you don't know the future about what can be produced, you can't really value money, and that undermines trade. So I think any big shock is just going to take everything down. The limits of preparedness are immense because we have a particular configuration of a complex society. If it falls apart, we're in a largely ongoing catastrophic situation. So all we can do is what's the best we can do with what we have at any moment beforehand, and how best can we sort of bias the dice so that things might turn out a bit better. So in that sort of way, I'm a pessimist about our ability to really do huge amounts, but I'm an optimist in the sense of one goes forth and faces into these things as best one can.
Fantastic. Caroline, your work focuses on resilience and sustainability, particularly in the context of natural hazards. How can this mindset apply to mitigating catastrophic electricity loss?
Well, that's a really huge question, and I guess I should start with just not defining key terms, but trying to talk a bit about the difference between resilience and sustainability. And of course, well, resilience has been around for the last 15 to 20 years. I guess it emerged, I guess, in the wake of sustainability as the buzzword of the 80s and 90s, and the triple bottom line sort of accounting for things. And resilience was really seen as an approach where it was a process of building capability, resources, networks that would support a community to be resilient and to hopefully be sustainable. And I think more and more these days we're seeing challenges to that idea of sustainable communities, because you can be as resilient as you like. If you live in a coastal location and your community is going to be taken over by the ocean and the rising sea, then you're not, unfortunately, you won't be sustainable in that location. So I think there are obviously some very key differences between those terms. It's interesting that resilience came from the engineering field back in the day in the 70s, of course. But now it's much more a people-focused word. It's about society. It's about societal readiness, preparedness across, I guess, in New Zealand, the context of the 4 Rs of emergency management. And that was put into legislation in 2018 with the National Disaster Resilience Strategy. So again, very heavily weighted in favour of people, communities, well-being. And so, you know, I think that was a really important move for New Zealand, and it's sort of happening around the world too, where people are very much at the centre of these issues, of course, as they should be. So, you know, in terms of mitigating electrical, what was the question? Electrical loss, catastrophic electrical loss. Of course, there's a lot we can do technically to try and improve our networks and find technical solutions, but there are so many human-centered or soft solutions that we can find, and that largely lands with individuals, with communities, with you know, local, regional, national government to enable and support and resource you know, resilience at various levels across society. And I think that's probably one of the most important things that we could be doing.
So if I could just jump in there as well. So in the study that Simon Bluen et al. Did about the US food supply chain, they noticed, you know, something really quite simple, which is that there are 2 scenarios: a 2-month outage due to a cyber attack and a 1-year outage due to electricity outage due to a nuclear EMP. And there was a big difference in the food consumption, so how much food actually got to people's tables. In the shorter scenario, the 2-month scenario, based on how much food people had at home, 3 days versus 10 days. And it made a big difference. As you can imagine, if you're down to half supply, you know, you can use that 10 days across 20 days to get a full supply. So it makes a big difference in a relatively short outage of 2 months. but it made almost no difference in the 1 year outage because it runs out very quickly and so forth. So yeah, there's clearly these quite simple resilience measures that we can do that obviously should be encouraged. But I also would just like to bring people's attention to a related issue where I saw the New Zealand National Fuel Security Study, which came out a week or so ago, a couple of weeks ago, and they had analysed a scenario of a 90-day liquid fuel supply stop to New Zealand. So we got nothing for 90 days, and basically had come to the conclusion that given our onshore stock holdings, the food in our fridge, if you like, we could muddle through that 90 days based on COVID level 4 lockdown consumption rates of fuel. Of course, what they didn't look at was the 1 year scenario, and it completely changes for that. So yeah, so I just bring that up as maybe a discussion point for related issues to do with other infrastructures and utilities. But yeah, thanks for those points, Caroline.
Thanks, Matt. Do you want me to respond, or are you going to ask me another question, Pia?
Whichever you prefer.
Well, I totally agree. I think we need to be thinking about these catastrophic risks, but in our experience of looking at the Alpine Fault as a case study, it was considered a maximum credible earthquake for that particular for that fault, and that sort of provided a decent enough challenge, I think, at the time and over the last 8 years for people to consider. I think a catastrophic global risk like this, yes, we need to be thinking about it. Yes, we need to build resilience to those sorts of events, but there are certain things that we have very limited control over in terms of feeding communities for 1 year without any resources required to move things around the country and supply chain breakdown and all of those things. So there are certain things that we're just going to have to rough it really badly, and it may not be solvable, but we can work really hard at the grassroots to improve local food networks and to do distributed electricity infrastructure so that there's microgrid and local supply and those sorts of things, which I think are part and parcel of a sustainable low carbon transition that we should be prioritizing anyway, which should help to improve our readiness for those sorts of seriously catastrophic events.
Yeah, 100%. And one of our pieces of work actually looked at we wondered how much urban agriculture could contribute, and the answer is not so much, maybe 20% of a city, but there was a surprisingly little amount of near urban industrial agriculture that could then feed the city, and yet like 30% of the land area of Palmerston North, for example, adjacent to Palmerston North. But of course that's if you can actually get the agriculture there, and that's to do with zoning issues and land use issues and stuff. And so I guess my vision would be that we work towards a New Zealand where land is zoned in the right way and wheat is grown near cities and people do have 10 days of food at home and these sorts of things. So yeah, just putting that out there as another avenue for thought.
Yeah.
And just in summation, Caroline, if you could wave a magic wand and create the ideal infrastructure for resilience to electricity loss, but across all capitals, human, physical, natural, financial, where would you focus your efforts?
Well, that's a really good question too. I think, well, our experience with the Alpine Fault work over the last 10 years has really given me a real respect for our emergency management system. Of course, it has challenges. You mentioned the report that's just come out of NEMA about the North Island severe weather event, and we are under-resourced. We don't have capacity and capability in emergency management. It's a very difficult sector to resource across all levels. So I think if I could wave a magic wand, I would say we have a really strong workforce in emergency management, and we have really good connections across the networks from local, regional, inter-regional. And this is one of the lessons we learned from AF8 was as a program that was the first one to be funded by the Resilience Fund, which was McDam Ministry of Civil Defence Emergency Management's funding at the time. First one that was really about an inter-regional project. At the time, it was very focused on CDM groups, the regional response to these sorts of disruptions. And that was the first time it had sort of gone across inter-regionally. And I think there's huge value in doing that. And we've seen, I think we've leapt ahead in terms of the network of people knowing each other across those regions and knowing who to call when disruptive events happen. And we've seen really strong evidence of the value of that. And so, yeah, we need to resource these things. We need to acknowledge a te ao Māori kaupapa-led approach to these things, and where people are very much at the centre, where everyone's looked after. And I think there are some nice examples there of, for example, Ngāi Tahu, the South Island, the major iwi down south, working on their own system of caches of supplies for their marae across the South Island, also working on their own sort of communications, videos, animations that they've done of the Alpine Fault to really bring it to a whānau and hapu level understanding of the risks posed by the Alpine Fault. So yeah, right across there, and we really need strong and cohesive communities with high risk literacy, and that requires a lot of effective communication, public education, all of the things that we need to support communities to understand the hazardscape that they live within. We also found through AF8 a huge thirst for knowledge from individuals, from communities, to understand the risks that they were living within, because without knowledge you don't have the power to make decisions and to be to show that you have self-efficacy to make a change and to build preparedness for yourself and for your people and your business and other things. So there are so many things. I mean, it's just a huge tapestry of effort that we could put into if we could wave a magic wand. Yeah.
Super. David Keat, you've held leadership roles in the oil and gas sectors and have dealt with major outages in those industries. How do electrical failures impact energy systems, and what are the broader implications for society?
Well, first of all, I'm very pleased I followed from Caroline. Caroline covered a lot of the, call it soft societal issues there, right? So I can maybe fill in the other half, which is the hard engineering bit about equipment and so on. Although I completely agree with everything she said, and I might have said it if I'd come before her. But so to answer your question, an electric power outage has a dramatic effect on basically anything that's run by power. So if you're talking about a large oil and gas installation, which is my experience, basically you lose everything, and the challenge is to try and release the vast amount of hydrocarbons you have in a safe manner and avoid an environmental catastrophe and an explosion, all those bad things. So of course the oil industry is very experienced, and maybe if I talk a little bit about that because it's analogous to the wider society. The oil industry has quite a structured process. First of all, they think about the scenarios in advance. And that's defined for us the scenario we're talking about here, which is a many weeks or a month or 6 months outage. But of course, they can be much shorter or whatever. But so it's very important to have that in mind at the beginning. The other thing, if you're talking about physical equipment, is the failure mode. So you talked about a cosmic ray, a cosmic storm, or an EMP. At a technical equipment level, that will affect your equipment, my equipment, Caroline, David's equipment differently. And you know that in advance, so you can try and protect against it. So if you know the failure mode of the equipment, you can try and minimize or mitigate the thing. So the oil industry process is to define the scenario, and then you try 3 steps. You try and avoid it. If you can't avoid it, you try and mitigate it. And of course, once you've mitigated, you go for a rapid recovery. And those 3 steps, I think, apply to us as a society and as a country. So I think you said, and what are the broader implications for wider society? Well, I think, Matt, you defined critical systems as electrical and telecoms, and I would, with my background, add oil and gas to that as well. And they're absolutely interactive. The study there showed we can go 90 days without an external fuel supply. I think it's actually probably a great deal less before it gets extremely serious. I'd also observe that that's based on a COVID kind of model where we were pretty much in our homes, not moving much, but also we're essentially being funded by borrowing money from foreigners, using electronic systems internationally. And, that kept society reasonably calm and things going, right? In a situation which is truly catastrophic, we may not be able to have access to international finance and do what the government did at the time. So it could get a lot more back to the Middle Ages-ish, if you like, along the lines of what Caroline was talking about, where we're actually trying to grow our own food and, really be much more self-sufficient. So the wider side of society implications are very great. Certainly in the short term, you get things like hospitals run out of diesel for their diesel generators and the lights go off. Food supply is obviously affected very significantly, very quickly. Government services like the police, fire service, rubbish collection, all those things struggle to perform without a decent telecommunications system, electronics, and obviously fuel. Then you've got things like the stock exchange goes down. So all those millionaires don't know what their net worth is at any one moment. So that's very serious. I think as the days and the weeks click by, you can see how there would be kind of points of inflection where at first we're kind of okay. You know, we're a bit shocked and we're reacting. And then we bond together and we do really well as a society, because New Zealand is a very good society. We're good at reacting to things. So we look after each other and so on. But you can see as things get further away and we actually start to run out of food and so on, that I'm not a social scientist, but you can imagine there are points where it starts to get much more difficult and you start to close in or look after your own, but no one else and so on. And then I don't think we'd end up with 1984-ish, but I think that's worth considering from a social science perspective, how long we can go before things get kind of tricky. I'm not an expert, but that's just an observation. That's a long answer. Is that enough?
Yeah.
That's it. That's a great outline of some of the cascading failures and interdependencies between infrastructure. Do you think that we fully understand this risk in New Zealand? And should
I don't think we do.
Yeah.
No, and the reason is because it's really hard to imagine. I really like what David and Caroline and Matt, I think, said about exercises, because there's nothing better than a simulation role play to find out where it doesn't work. In the oil industry, we do those on a regular basis, like weekly, monthly, annually, obviously at cascading levels. And they always go quite poorly because everything is supposed to be fine and then it doesn't. You know, someone's supposed to ring someone and then the phone is down or the person isn't the other end because they're doing something else. And that's why you do the exercises. And then when every so often you have a real one, and it goes quite smoothly because of all the practices. So I think exercises at a national scale are a really good idea for things like this. No, I don't think we're prepared enough, of course, because everything is interconnected. Do you want to ask your next question?
Yeah, go for it.
Just further, do you think that we should be expanding on the regional studies of interdependencies, such as the one recently conducted in Taranaki, but up to the national level?
Oh, yes, I was meaning the question after that. Yes, I sort of just addressed that really, because yes, definitely studies are a good idea. You can have too many studies. We do need a national coordination. I think we had an example in the recent East Coast cyclones, right, where you could say the initial response was actually not too bad for the first 24 hours. It was an unexpected event and everybody mobilized and it was okay. I would say there was a lot that we could have done better in the weeks and months that followed, which is exactly the scenario that you outlined, Matt. This is not a 24-hour car crash kind of scenario. This is a step change in the way New Zealand is operating for an indefinite period. And we all will have to adjust to that as fast or slow as we can. And it may not be within our societal ability to, certainly things can't carry on as they were before, which is our normal expectation as humans. This is a change. And I don't think without proper studies and exercises, we can even define what that change looks like, what that end result is.
I think just to really quickly comment on that, I think that's a really important point. And just the messaging that sometimes if bad things happen, you can't expect a full recovery. You can't expect full compensation. You might have to muddle through. And to, look, I worry that we are entering, as the UK PM said, an era of great instability, and, catastrophe will become more common. So I think the messaging needs to be honest, and the public conversations need to be honest.
I definitely agree. I would make a more general observation. Speaking as an oil guy, right? The general story from our politicians and leaders around the world on climate change is that don't worry, we'll do stuff and you don't have to change your behavior. Well, it's actually the reverse. We all have to change our behavior if it's actually going to make a difference. And I think in your disaster scenario, it's probably something similar. We really do have to change our behavior if we're going to get through this, with a reasonable outcome.
You've also advocated, David Keat, for electrical system reform in New Zealand. In your view,
question before about the key to building resilience.
Yeah. Yeah. In your view, what would a truly resilient system look like, and how would we practically build it?
Yeah, that's why I wanted to talk a little, again, as an engineer. So I'm coming at it from, I'm adding to the equipment part to what Caroline talked about, the soft part, right? In terms of how do you build resilience in equipment? Because at the end of the day, our electrical system is a bunch of equipment, and it's operated by humans, and there's procedures and a lot of human involvement, but it's physically, it's equipment. So how do you build resilience in that? Well, the first thing is you think about the scenarios. Matt's defined one here, and there are many others, of course, the alpine fault earthquakes and whatever. But what's the scenario you're trying to protect against, particularly the duration of the outage? Then you try, the first thing, remember those three things, you try and avoid it if possible, so there's no impact despite this event. If you can't avoid it, you mitigate it, and then you go for a fast recovery. So in terms of avoiding a cosmic ray event, you really have to look at what a cosmic ray does to this cable or this pylon or this split piece of switchgear or whatever. Now, I imagine a cosmic ray event won't do much to a pylon. The pylons will still be standing. It may be that the cables are still standing, but anything electronic is probably going to be fried. So maybe, but you have to look at the detail. So then how do I stop my electronics being fried? And you can imagine things like conceptually wrapping the substations in aluminium foil, although it's obviously more technical than that. But you say, I want to have this substation robust under any cosmic storm of any intensity. And if you give that to a bunch of engineers, they will be able to solve that problem. So you define that as the problem, and then that means you mitigated that particular piece of equipment going down, and it will stay on in this scenario. So you go through the whole system like that, looking at how can I protect this equipment. There's a second level, which is standard in an engineering world, where the famous N+1 law, where if you have a failure, a piece of equipment which will fail, like a switch in a substation has a failure, they don't have infinite life, they will fail. If you really don't like the consequences of failure, you add one more. So 1 + 1 is 2, so you add a second one. And the idea being that one of those will fail, and when that happens, the other one carries on, and then you can replace the broken one, and the system carries on. So the outside world doesn't see anything wrong. So you apply that N+1 law everywhere. The most obvious example in New Zealand of that is the national grid, where we have two national grids from the southern part of the South Island all the way to Auckland, where basically it's a parallel set of pylons with parallel cables on. Either one of those can carry 100 or more % of the load. And they do that because if, for whatever reason, one goes down, the other one carries on, and the country can carry on. As we know, sadly, it doesn't continue north of Auckland. And Transpower recently demonstrated that by taking a power line down, and North Power went out. But you can see the N+1 law wouldn't have had, if that pylon had gone down south of Auckland, nobody would have noticed particularly. So there's that. And then in terms of not so much a cosmic ray storm, because that's countrywide, but as a general rule, you try and have geographical and technical variations, I should suppose, rather than redundancies. So it's really not a good idea to have all of your generation, any equipment all in one geographical area and of one technical type. So having all of our power generated as hydropower in the southern part of the South Island is really not very clever from a resilience point of view. Although it may be quite resistant to cosmic storms, it's not sensible, obviously, for all the obvious reasons. So we really want something which is not in the South Island, and it's not hydro, and obviously not oil and gas, because that has its own vulnerabilities in these scenarios. So that means wind, solar, geothermal, batteries, north of Taupo. So if you're preparing in advance for almost any outage, including a cosmic storm, you would do that. And again, you would make sure that your wind farm electronics were protected against, obviously, weather and also solar storm. So you do all those sorts of things to try and avoid it. Then once you can't avoid it, this event has happened, then you get into mitigation. I don't think we can mitigate in advance a multi-month outage. That we just have to wear that. You can do some things, obviously. You can prioritize some systems over others, because it may be that we have a partial outage. You know, the power system is down and it's only at 20% of capacity or something. I don't know exactly what would fail, in which case you definitely can prioritize hospitals and fire stations and the obvious things, rather than me watching Netflix. There's that. I know I was in Norway for a time, and they, by law, have to have 6 months of food in their basement. It's usually cans, of course. You could, if we took this seriously, you could do something like that. There's obviously obvious stuff about batteries on roofs and solar on roofs and all those sorts of things, and you could probably quickly come up with a solar storm resistant solar panel system. I don't doubt that for a moment.
Mm.
And then I was going to get on to recover. You've got your hand up there, Matt.
I was just going to say, I mean, hopefully Florian will talk a bit about the food issue in a minute. But
Okay, yep.
This idea of, you've talked us through how to different steps to make a electrical system, more resilient, as you say, prevention and mitigation, redundancy, these sorts of steps. But then you may get the scenario where, okay, it's gone, it's out. So then you want this, accept that it's out, and can we still operate things, and things. It would be great to have even a 5 or 10% operational capacity with no power for some of these utilities. So I'm thinking of petrol stations that might have electric pumps to pump the fuel from under the under the ground.
Yeah,
they have hand pumps or something like this that could partly function, or generator plug-in abilities, or things like this as well.
Oh, definitely. That's part of the mitigation or the recovery, really. You have things like spare parts. If you think your electronics are going to be fried, then you have a replacement electronics which are stored in the basement in a lead box kind of thing, conceptually, so that when this event happens, you bring it out and it's going to be working just fine. I think if you define the problem or Transpower and the electrical fraternity that we want to survive a solar storm, they will come back with a list of stuff that needs to be done, and then as a government, I guess, or a society, we can decide whether we want to do all of that and how much it costs and so on. But you can mitigate to a large extent, I'm pretty sure, if you go at a technical level. I just wanted to say one last thing on the subject. There's a cultural aspect which both David and Caroline have covered a little bit, but I'll give a real example. You, of course, are aware of the Fukushima nuclear disaster that happened in Japan. And you know that there was an earthquake and it cut the power. And when nuclear power stations shut down, they need to circulate their cooling water to take the heat away. The earthquake stopped the electric power, so they had diesel pumps as a backup. For reasons which I'll explain, they didn't think about a tsunami or a flood, so the diesel pumps were flooded and they didn't work. A few months later, after Fukushima, there was a 1 in 100-year flood in the Mississippi Valley. A nuclear power station there was completely underwater. But they shut down quite safely because their diesel pumps were on a platform 50 meters above the floodplain. So, they'd thought about it in advance, and the problem was solved. So why did the Americans get it right and the Japanese got it wrong? And the answer is, it's nothing to do with Japan. It's the culture of the company which was running the Tokyo Electric, a company which was running the power stations, was a very old-fashioned kind of male hierarchy, only good news travels up kind of a organization. So speaking from my world, it's almost impossible to believe they hadn't thought about an earthquake scenario in a country like Japan and a tsunami scenario, but they hadn't, and it's cultural. So we're not Japan, and that's not Japan generally. It's just that particular company. But that was the root cause, really, of that failure, not technical engineering stuff. It was the culture of the company. So New Zealand is not Japan. We're quite different. But I think if we're going to go forward on this, we should be very self-aware about the kind of culture we're in, and maybe blind spots that we have as a culture, and not weaknesses, but things that make us not as good at responding to emergencies like this as we might be. As a general rule, I'd say we're very good at quick response. We're not so good at slow response, as a general observation. But the cultural part of this is very important.
Yeah.
That's all I had to say.
I agree. I think with most things that we tend to ignore the importance of social technologies when we talk about different technologies, different plans, different strategies. Going to move on, thank you, David, to speaking with Florian. Florian, you recently blogged about a German study on catastrophic electricity loss. Can you highlight some of the findings and recommendations from that study, and is it worth other countries publishing similar reports?
Yeah, sure. And sorry again for my camera not working. It was working just fine before the call. Don't know what's going on there. But to talk a bit about the study, I think David Keat already touched on many of the points that were also highlighted in the study, with like electricity being the key for many systems. And the thing they also highlight again throughout the study again and again is that all our different societal systems are connected a lot with each other. The most severe case is usually like the connection of electricity and communication, because the electrical grid needs communication to be working, and communication needs the electrical grid to be working, because otherwise coordination gets really hard. And so if one of them fails, it becomes very hard to restart the other, for example. But you also run into like very practical problems in many of the more industrialized nations, because here in Germany, everybody is cooking at home at an electrical stove. But then even if you have, for example, rice around at home, but you can't cook it anywhere, well, you still don't have any food. And given all these complexities, the report essentially comes to the conclusion like after like around a week of without electricity, all bets are off if you haven't done any extensive preparations, because our societal systems aren't just built for for such events in mind at all. And so preparation here is an essential dimension, and also like just even thinking about these kinds of events, because often like the problem isn't that people don't take these events, these extreme events, not seriously. It's that they don't even think about them at all. And to get to the recommendations from the report, I think they make 3 key recommendations after they had analyzed the situation in Germany. And the first one was that they say, okay, we have to unify the decision making in some way, because in Germany, like the infrastructure is distributed throughout thousands of companies. And all these have to be coordinated in some way if electricity fails. And this is almost impossible. So in preparation, you have to unify these decision-making structures somehow. One example they make is you could, for example, nationalize again more of the important infrastructure, so you have it all in one hierarchy. Another point they make is that even though Germany has food stocks prepared for big catastrophes, so we have food for weeks to months lying around here, the problem is that storing this large amount of food is expensive. And so they decided to put these in few but very big storage spaces. And this is fine if you have like a regional or also local disaster. But if you have a nationwide disaster where also your transportation is affected a lot, well, then it doesn't really give you anything if the food is somewhere else in Germany, but you still can't get it. And the final recommendation they make is that we should think more and plan more for microgrids. And with this is what they mean is that it is very difficult to restart the whole electrical grid at once. But you could disconnect a part of the electrical grid, like a town or even a region, and only try to restart it in this area. So this area can then serve as a hub where things are working reasonably well. And the good news is that this is likely getting easier as we are transitioning more to renewable energies, because if you rely more on renewable energies, you generally have to have a more distributed and less centralized electrical grid in the first place. And in this less centralized grid, it also gets easier to do these microgrids. And to your last question, like if this is helpful for other countries, I think very much so, because like what I mentioned earlier, the important thing is like to get thinking about these things in the first place. And while many of the findings in New Zealand will likely be similar to the ones in Germany, I think there will also be like key differences. Like, for example, Germany has an emergency well system that was built in response to the threat of the Soviet Union. And so even like in extreme events, Germany has a relatively good chance of still providing everyone with water. And this is like a special case for Germany, for example.
Can I just...
yeah, sure,
sorry.
sure, go ahead, Matt.
I just wanted to add something there and direct it to David Keat, actually. You talked about sort of, the microgrid situation, or the sort of, islanding of the generation and supply, and that all makes sense. David Keat, do you, are there regulatory issues in New Zealand with respect to, sharing electricity amongst households and neighbourhoods and things like this that really should be addressed to increase resilience there?
Short answer is yes at the moment, but there's a more optimistic answer that I know at the moment the Electricity Authority have made their first tentative steps after 40 years into addressing that to some extent. So they'll be enabling some of what you want, and I'm not sure of the national program in this area, the coalition program in this area, but I'm fairly sure that the left-wing side of it are looking at, definitely, because they're much more focused on microgrids and call it community or suburb-wise grids. So I would imagine within the next 5 years, any roadblocks will be, other than the funding it, will be removed. But right today, and historically, yes, there have been grids. Essentially, the only way you were legally allowed to get power to your house before was from a lines company or go off grid entirely. Of course, there's a halfway house, which is what we need to move to.
Back to you, Pia and Florian.
Yeah, Florian, with your involvement in All-Fed, addressing food securities in extreme scenarios, can you explain what catastrophic infrastructure loss means in that context and how it would impact food supplies, and then what steps could be taken to mitigate that?
Mm-hmm. Yeah, I think when we talk about global catastrophic infrastructure loss, we are thinking about like the disruption of industrial capacity on a global scale. Because for many of the, if such an event happens local or regionally, then you usually can help just the region by bringing in from supplies from somewhere else. But if you have like a very large scale event, then things get much more difficult to navigate. And some of the possible causes for something like this were already talked about by Matt earlier, like having a nuclear EMP or like a geomagnetic storm. And this would like potentially disable the electric grid on a very large scale. And so coordination gets difficult. And so you have to think about what you do locally in such an event. And the way this impacts society very strongly is via the food system, because also like much of our food production works through our industrial capacity in the way that we are very reliant on fertilizers, we are very reliant on pesticides, we have irrigation systems, you need a tractor to be running. And if you don't have these inputs anymore, your yields could quickly like revert to a much lower level. And we did a study about this where we tried to simulate, okay, how big would these impacts be? And if you have highly industrialized agriculture, like for example, you have in Australia, then in such areas you could lose like 60 to 80% of your yields, which is just massive. And the question, like, what can we do to mitigate these things? I think like the first thing is what I already mentioned a few times, is that like even start thinking about it, because if you don't even plan for it, like then truly it gets much more difficult. But also in All-Fed, we look at potential solutions, what could be done even in such a event to create enough food for all the people affected by it. And one of the examples I could make for the global catastrophic infrastructure loss are things that need to be relatively low tech, so you can do them even if your industrial capacity is disrupted. And one of the things there that I did research in for a few years was seaweed, because seaweed is eaten already in many countries. It grows really quickly, so you have the potential to scale it up. And also, many of the seaweed growing we do today is also very low tech. So you don't need like a gigantic industry to run this. So, but you can also do it locally, given you are near an ocean. But this is like one of the examples we looked into specifically.
Great. Pia, do you think maybe there's another question for Florian, but then perhaps we could do around the panelists now that they've heard a bit from everyone, key thoughts and critical actions or something like that. You're on mute.
Yeah, it'd be great if we bring anybody back in to have a comment, hear more from Caroline and David Korowicz again, and then we do have a couple questions from the audience as well. So, David Korowicz.
Hi, let me just check this. Yeah. I think one of the key points is that the outcome of a shutdown in the flow of goods and services is common to all sorts of crises. Failing financial systems, fuel supplies, grid failure, or interactions of things due to extreme weather, etc. So when you prepare for one, you prepare for all. So that's the first point, that it's not these things used to be referred to as high impact, low probability. I think the probability is escalating rapidly for this outcome. So I think that's the key point of preparedness, the general point of preparedness. The second thing I would say is that when we talk of a really large catastrophe, because of the inherent complexity of society, because of how it has self-organized and how it progresses, if there's a big enough shock, very quickly it'll become irreversible if it's on a large enough scale from whatever set of causes, initial causes. And there is a point in terms of preparedness planning where you're kind of going, is this going to be temporary or is this going to be long term? And if it's long term, you have a pretty existential predicament, depending on where you are and your preparedness. Because once things are down, you know, in a large enough area, you've lost your capacity to recover. And when we've looked at food security issues before, one of the issues was, well, people don't have seeds, people don't have tools, because they're not in the system, because we're not a nation of people who produce food. And if you can't keep your tractors going, etc., you can have just lots of things not there. So that for all countries, including civilians, as they say, there needs a sense, I think, a sense of really quite urgent, comprehensive preparedness planning. And just on the point of food at home, and this was alluded to by David, there is the psychological idea of scarcity can become pretty destructive to a society's collective capacity to keep going when the initial coming together starts to wane. And one of the values of getting a community focus is that you build structures. So rather than people saying, what will I do or what will my family do? You say, how can I help? It's a different mindset where people contribute. And this gives other types of benefits to community in terms of security and coordination. So that is also part of preparedness planning in terms of building capacities, is building that sort of cohesion that will hopefully help to weather out longer term disruption.
Great.
Okay.
Caroline, did you have, or Matt?
No, I was just going to say, Caroline, further comments?
Yeah, thanks. I guess, you know, from a social science perspective and all of this, when we consider catastrophic risk, we've got to be very careful about the perception of risk amongst society. I'm thinking of individuals who, in response to something that significant, become quite fatalistic. There's a real tendency for us to think, well, this is far bigger than I can possibly manage, so I'm not going to do anything at all. So that fatalism is a real threat to preparedness and societal resilience. So my personal view is that, you know, giving the public an understanding of moderate events like an alpine fold event, which in comparison to your nuclear meltdown is moderate and manageable, that's enough of a challenge for them to think about what they would do, and it's probably enough for them to build a certain level of preparedness. Now, you know, in New Zealand, we've already moved beyond get ready for 3 days to get ready for several weeks, a couple of weeks. When we talk about an alpine fold event, that's progress. You know, I think we used to only try and, you know, have 3 days worth of resources. So I think that's, you know, we want to build agency amongst the population. We don't want to overwhelm and lead to fatalism. So that's one point. I think exercising these sorts of catastrophic risks in the local, regional and central government level is really important. And I think, you know, DPMC and our central government agencies should be thinking about these major catastrophic risks and are thinking about them. So it's early days, but there's still a lot of work to do. And, you know, we often think about disaster as, you know, there's opportunity in disaster. And I'm really curious, I don't want to ever live through one of these, but in the event of something this terrible, what will emerge in terms of opportunity? And I think there are, you know, there'll be communities out there that actually do function and continue to do okay in these sorts of circumstances. I'm thinking of rural communities that have access to food. And, you know, there are situations like on the west coast of New Zealand, farming communities that will just go out into the bush and get their food and continue to exist much like they always have. They'll be challenged by things like lack of health care and lack of supplies and things like that. But for the most part, they will get through many months of disruption, I would suggest. Obviously, urban environments are very different. We'll have cities that start to collapse because people don't have enough resources, the scarcity issue that David Korowicz talked about. So yeah, I think it's, yeah, I think that's probably all I wanted to wrap up with.
Great. David Keat?
Well, listening to everything that we've said, one of my strong conclusions is would be best to try and avoid it as much as possible. Obviously, you can't avoid what happens in the sun or whatever, but I think we probably should be doing more than we are now in terms of preparedness. Caroline just outlined, and David very well, some of the soft parts of that, and we should do a lot more of it. But there's also an equipment aspect to it. Like I was outlining in my talk earlier, I think I would be surprised if our national infrastructure systems even have a scenario of a solar storm taking everybody out for a month. I'd be surprised if it's even in the design criteria. So that's something that should be checked. The other observation is I think we've got, I don't want to be too negative, but we've got about 10 billion people on the planet. And what was it? 2 billion when I was born in 1960. So the remaining 8 billion are sustained by global trade, high technology, tractors and farms, fertilizer, all that kind of stuff, right? If that supplies all of that stop for more than, say, 6 months, then you really are going back down the historical curve. I think New Zealand would be okay. We're an island, although we might be invaded, but for much of the world, that would get quite serious, I think. We just can't sustain this number of people, and then you end up with societal breakdown in selected areas. So I think that's not something we should plan for exactly, but you could sort of see it playing out that way in one or another scenario. But having said all that, as a techie guy, I think we could mitigate it a lot better than we have up to date. If we just focus on it, I think we can get through this more easily than we would if we did nothing.
Florian, I guess some of the comments that David's just mentioned are kind of leading directly into your area of research. So So what are your sort of final comments before we go to audience questions?
Yeah, definitely. But actually, like I wanted to build on a bit on Caroline's comment, because I feel like in the research we've been doing at the Alliance to Feed the Earth and Disasters, I think we can now reasonably certain say, like, even in like very big catastrophes, you still have the potential to produce enough food for everyone. Like there's no physics stopping you from doing that. But what the actually tricky part is like the societal reaction to these events. Because, for example, you have the way we have set up the trade system right now, you have very few countries that just export a lot of food, like Brazil or Australia. And if you have such a catastrophic event, one of the most tricky parts will be to keep that these countries keep on exporting food, because we have seen, like in the past, often even if with relatively minor shocks, that countries start to introduce export bans for the food they're producing, even though they still have more than enough at home. And I would definitely love more research in this direction, and also like maybe that countries agree with each other beforehand, like, okay, even in such an event, we would still trade with each other because we've thought about it in advance. And like these thinking about it in advance is just like, I think the key message here from all that we've said, because we need more research here to understand what's even going on. But also I loved by David Korowicz, the example with the tabletop exercises. I think these things are just very important to understand what might even happen.
Great, thanks. Pia, have we got some audience questions there?
We do have some audience questions. This one directed at David Korowicz, but I think both Davids have mentioned the financial system, and it may have spun the audience. The question is, you mentioned impacts of catastrophic events on the value of money. I didn't quite catch the logic, but it seems significant. Do you have any resources, or can you further explain the impacts on monetary and financial systems?
Well, if we think that what we're doing with money it's effectively a future prediction thing. So I go into a shop tomorrow with my money and I get something in return. So it's saying something about tomorrow. And if I don't know the value of future production, because it's very uncertain, because I don't know if things will work, how do I value money? So when I start to get involved in trade, and remember, we have a hugely complex, unbelievably complex system underpinning, interdependent system underpinning how things work. If you go into your shop, your factory, or whatever, how can I sell you an input? Will you sell me an input if what I give you is this uncertain digits? Because there's no shortage of creating digits. Anyone can create paper. The problem is it's contained within a predictive system that we all take for granted, and that requires functionality into the future, productive capacity, and ability to predict that. So that is, in straightforward terms, very natural, and it's just we so swim in money that we take it for granted. If you're looking for a reference, it's pretty old now, but if you go to my website, there's a thing called Trade-off: Financial System Supply Chain Cross-Contagion, a study in global systemic collapse. So you can have a look at there. But in a sense, just ask, why would I give you money for anything? Why would I sell you money for anything if we don't know the future productive value of the money that I give you? Why would you work for me? Why would you contribute to something? And especially with the complexity of inputs. So I might barter with you for a simple thing, but the world we live in is too complex for that sort of coordination.
Can I just, on a related issue, talking about actual transactions, maybe I can just throw over to Caroline. I noticed that the 2023 New Zealand National Vulnerability Assessment specifically stated that they had excluded, point of sale transactions and financial transactions and stuff, and they were going to address it in a future iteration. Has the AF8 work revealed any key learnings about, you know, how people get stuff if FPOS and so forth aren't working?
That's a good question. And no, we haven't done a lot of work on bartering and trade and sort of lack of currency issues as a part of the program, to be honest. We haven't, no.
Yep, perhaps an area for some urgent research. David,
if I could just briefly come in there. The financial system is an interesting one in national risk assessments, precisely because it's what it's called reflexive. So if people start saying, you know, the financial system is about to collapse, you know, the preemptive thing you do is everybody starts taking money out of the financial system, which is the type of thing that can destabilize the financial system. So often it's in the secret part, or it's not referenced in much detail in national risk assessments.
I would just add, though, that there was evidence after the Canterbury earthquake sequence of a bartering system that was set up in Littleton. It was the Time Bank, I think it was, where people would offer services and goods and trade for other things, and that worked in a local community really well in terms of having no cash available, so people were just supporting each other in that way. Just as an example. Sorry, David. Keat?
I just have one observation. A lot of the financial transactions we do are with people we don't see and may never meet. Obviously, if we're buying bananas in a shop, we're talking to the shop assistant and we swap some money, and that can become a bartering system relatively easily. But overwhelmingly, we're buying services from in New Zealand. It could be someone or a system which is at the other end of the country. But easily these days it's internationally, and the whole basis of international trade, international finance, and everything is based on essentially a trust that the money I'm putting into this void to someone in China who would buy a system which is then going to Brazil and whatever, you just trust that it's all there, it's all working fine. In a cataclysmic outage like you're describing, Matt, that trust has got to be optimistic or possibly naive. So then how does that all flow through? You end up stop doing those transactions and the thing winds itself down. So although you can get by with the banana level, but overwhelmingly the volumes of money flowing around the world financial system are not for bananas. They're for much more complex and much bigger things. That bit is all at threat, I think.
So can I? I'm just aware of time, Pierre, that we've sort of only got 6 or 7 minutes left. I did notice a question in the Q&A that says, how do we ensure that all these insights reach the key decision makers in the country? And this is, I guess, something I was hoping to bring up. You know, what are the leverage points for action? And you know, I had a few notes down here that, you know, there are things floating around, like DPMC's working on their next long-term insights briefing, which looks like it's going to address global risks and things. The Infrastructure Commission has its priorities program that people can submit to. You know, NEMA's iterating this space weather plan and catastrophic event handbook, and there's a national fuel security study that's just come out, which should feed into an updated national fuel plan. And there's probably a bunch of high priority research needs and so forth. But look, I agree. How do we express or convey the desire for solutions here to the powers that be? Anyone?
Maybe to chip in, perhaps just to kick off in response, I think, well, it's multi-pronged, and I think DPMC certainly are thinking about these sorts of risks. And yes, the space weather response plan is brand new, and it needs a huge amount of work in behind it, because it was really just pulled off the shelf from the Australian response plan. And so we need to really dive into that in terms of a country and figure out what it means for us in New Zealand. So yes, the scenario around that needs a lot of work. And Craig Roger, his office is just across campus from mine, and he's certainly feeding into that process. But scenario development is the key skill set here. And I think that that NEMA needs to drive that forward with his and other science input. There's also the research sector, and I think there's a real opportunity at the moment through what's emerging now is the next iteration of the Resilience to Nature's Challenges program, known as the Natural Hazards and Resilience Platform, is being shaped up right now. And actually next week, a group of us in the design team will be working through some writing tasks to try and put a work plan together for that. And that's a 7-year program. So we're seeing a continuation of RNC as it was. And these are mission-led research programs that have these sorts of issues in mind. And I think one great thing about this NHRP is it's seeing a real merging of the climate and geophysical hazard space into one. So we sort of had a divergence in the National Science Challenges around the Deep South program and the RNC program. And now we're coming together for a full multi-hazard sort of program of research. And so, yeah, there's a real opportunity there to feed in these sorts of issues.
I just had a comment. I wanted to share a comment that was in the chat, which is that the financial system will be made a critical lifeline in the next iteration of the National CDM plan.
Great. Any other panelists with comments for the last 3 minutes? I guess I would also like to jump in perhaps then with one of my usual rants, perhaps, is that risk governance of these very large scale risks, I think is in a lot of senses they're not really covered by New Zealand's risk governance and risk management systems, and when they are, they're sort of in bits and pieces. And it would be great to see a genuine anticipatory program of governance of these sorts of issues with an accountable lead, someone who can look across these various plans and reports and response plans and so forth that are out there, and look beyond the short-term response and look to the investment in infrastructure upstream and things like this with a whole society and whole system view, perhaps a chief risk officer or commissioner or something, with cross-border coordination, with Australia, like, can we even trade with Australia if global shipping lines have fallen down and things like that? Do we have the ships and infrastructure, and citizen voices, where we put cost effectiveness analyses to the public? Look, this is what this costs. This is the sort of resilience you'll get from it. Are you prepared for that trade-off, and loss of potentially other services across government? Do we want to be resilient to catastrophe, or do we want to take that risk and have day-to-day services at a certain level? And perhaps there needs to be some legislative framework, maybe like in the US, that mandates regular assessment of these kind of global catastrophic risks or large-scale national risks, like the US Global Catastrophic Risk Management Act. A lot more I could say on that, but I do like to push that message. Maybe we can have a joined up risk governance system. Florian.
Yeah, just a quick comment. Like, when I was doing my research about the whole societal collapse for my literature review, one thing that came up and again is just like having more democratic processes is really very helpful if you want to have a more resilient society. And especially as things like citizens' assemblies have shown that they often provide very forward-looking ideas to better prepare a society for future negative events on all kinds of scales. And if we had more of those, I think this would be a great way to both have prepare for more resilience and also make people aware of it, and also have like a better societal uptake, because these suggestions by citizen assemblies are often like very well received, because people see that these come out of discussions of ordinary people who have thought deeply about the topic.
Great. So I guess, Pia, over to you for some final comments.
Yeah, I just wanted to express that thanks, but first that in the coming days we will distribute some comprehensive show notes. We'll publish a summary and a commentary on our blog and post the full video recording to be more widely shared. And I'd like to emphasize that we will address any unanswered audience questions as well. And just in summation and closing, many thanks for your time, everyone, and attention in joining us today. We're genuinely delighted to have attracted such a large audience and are very grateful to our esteemed panelists for their depth and contribution. Islands for the Future of Humanity is a charitable trust. We welcome any donations to further our work if you're able to do so, and we look forward to this being the first of many events. I encourage you to explore our website, islandfutures.earth, if you haven't already. We continue to expand our repository of papers, and there are regular blog posts as well. And on behalf of Islands for the Future of Humanity, I'd like to thank everyone very much and wish you a good night.